Hello Bobcats. Today we are going to discuss, in this video, we're going to discuss dimensional analysis, also known as unit conversion. In order to do a dimensional analysis, we first must talk about what we call an equality statement of units. And we use equality statements of units to create or make conversion factors, which are ratios of those units. So the one I'm going to talk about here is that equality statement would be 1 foot is equal to 12 inches. Now we notice that 1 does not equal 12, but because we have units of measurement here, we know that 1 foot is equal to 12 inches. So this is an equality statement of these two units. Now, to convert over to conversion factors, or to make conversion factors, I'm going to go through a couple of steps that kind of help with the logic of this. So if I take 1 foot is equal to 12 inches, and I divide both sides by 12 inches, we notice that the 12 inches reduced to 1. So 1 foot over 12 inches is equal to 1. And if we also say 12 inches is equal to 1 foot and divide both sides by 1 foot, the foot reduces to 1 also. And we notice that in this case both 1 foot over 12 inches, which is a conversion factor or a ratio of those two units, is the same as 12 inches over 1 foot, because they both equal to 1. Each one equals to 1. So this is a conversion factor. It's a ratio of those two units or measurements, and we can use it to convert back and forth from feet to inches. And the reason I show this is because a lot of students feel like maybe the ratio is stuck as feet over inches, but it doesn't have to be that way. It could be the reciprocal of inches over feet, and they both give the same information, but they are used differently in conversions. And so we're going to practice this in just a second. So here are conversion factors made from this equality statement that we have up here. Okay, now the best way to learn about dimensional analysis is just to practice it. So let's go ahead and practice our dimensional analysis. The first problem, let's do something that is fairly straightforward. How many inches are in 3.84 miles? And the equality statement, then why did I put an exclamation mark? That should be a question mark. Okay, question mark. Now the equality statement that I'm going to give you is that 1 mile is equal to 5,280 feet. Okay, so that's what we're going to use to work on this conversion. Now to do this, the steps that we need to think about are that we have miles, so we can start out with miles. And then we know that we can convert a mile to feet, so I'm going to go from miles to feet. And then you should know that 1 foot is 12 inches. Well, we just gave you that equality statement up here, so we can go from feet to inches. Now in this case we're going to have two conversion factors. Each arrow would be a conversion factor. And so let's go ahead and get started with this problem. I suggest that you should always start out with a question mark of what you are looking for. So I am looking for inches in this case, and I want to know how many inches are equal to 3.84 miles, and I'm just going to put MI. And we're going to use, I'm going to show you two formats for this. The first format is just a fraction format where we take and we're going to multiply by another fraction. So this will be one, this arrow here would be this conversion factor, which, because miles are on top, I'm going to need to put miles on bottom, and we're going to convert miles to feet, so feet on top. We know that 1 mile is 5,280 feet. Okay, so now miles cancel, and then we're going to need the next conversion factor. And if we have feet on top, I'm going to put feet on the bottom, and then feet can be converted to inches. And we know that 1 foot is 12 inches. And so the feet cancel. And now, if you'll notice, the reason I put an equal sign is because I want to know when I can stop. Once I get that unit of distance to match this unit of distance, then I don't have to do any more conversion factors. So I do an equal sign. Now this is one format. The other format is the one that I will always be using, so you need to be familiar with it. And that format is this. It's the same idea. How many inches are equal to 3.84 miles. But now I'm going to use a grid format. So there's multiplication here and multiplication here. So in my grid format, this line is a division line, which is the same as these here, and then this line is the multiplication line. Again, we have miles, 2 feet, and so 5,280 feet in 1 mile, and the miles cancel, and then 1 foot is 12 inches. Feet cancel. Now it's this bottom format, this grid format, that I will be using, so you need to be familiar with it. You can use the top format if you would like, but I prefer to use the bottom one. Now, when I put this answer down in a calculator, so I'm just going to multiply 3.84 times 5,280 times 12. I don't worry about the ones right now. So when I do that, I get an answer in the calculator of 243302.4 inches. Now, we don't want all of those numbers. That's what the calculator gives us. We need to figure out how many significant figures we're going to route the answer to. Now remember, we do not use defined numbers such as 1 mile is equal to 5,280 feet. We use measurements to determine significant figures, and from the original problem. So here's my measurement. So I have 3 significant figures, so I want 3 significant figures. So I can then write this problem, this number, as 2, 4, 3, and then 0, 0, 0 inches. Now that's a big number, and there's only 3 significant figures here, so we are going to write everything, all our answers, in scientific notation unless it's smaller than 1,000 or bigger than 1,000th. In other words, 10 to the negative 3 or bigger, and 10 to the negative 3 and smaller, or 10 to the third and bigger. So this is 2.43, and then I got 1, 2, 3, 4, 5 places, so that's times 10 to the 5th inches. And I still have 3 significant figures here, and it's written in scientific notation. So now, from now on, I'm just going to use the grid method down here. So we're going to practice at least 3 of these today. So the next one will be, how many centimeters are in 6.2 miles? And my equality statement is going to be 1 mile is equal to 1,609 meters. That's my equality statement. Now, the thing is, what we're doing is anytime it's in like miles, feet, or inches, we call those standard measurements, and these are metric measurements. So there's a conversion between standard and metric measurements here. So when I look at my equality statement, I have a standard to metric, but then I have to take this metric to this metric. Now, I will, on the test, always give you equality statements, and you should always use the equality statements that I give you. I may give you more than you need, so you need to pick the correct ones, but you should use the ones I give. Don't go online and find others to make shortcuts. You use what I give you, and then but you have to memorize the conversions from one metric to another metric measurement. Now, in this, we know that we need to go from, we start out with miles, so we're going to go from miles, and here we can go from a mile to a meter. There's my standard to metric conversion, and then we got to go from meters to centimeters. That's my metric to metric conversion. So when we start out, we will start out with question mark. What are we looking for? We are looking for how many centimeters are equal to 6.2 miles. Okay, now you can't put an M because M stands for meters. We need miles. Now again, since I can go from miles to meters, so miles are on top here, so I put them on bottom over here. Then I'm going to go from miles to meters, and I always deal with the unit before I deal with the number. Now, we know that 1 mile is 1,609 meters. So miles cancel. Next step. We're still not there because we're at the meter distance unit and we need a centimeter distance unit. So meters are on top, so I'm going to put meters on bottom. We know we're going to go from meters to centimeters. Now, I put a 1 next to the bigger unit. The bigger unit in this case is the meter. And I want to know how many centimeters or smaller units make this bigger unit, and it's 100 centimeters makes 1 meter. Meters cancel. Now, I'm at the distance unit that I want to be, so I don't have to put any more conversion factors. I just multiply across the top, and I don't have to divide by anything because these are ones. So when I multiply, I get an answer of 997,580 centimeters. Now, how many significant figures do we want? Well, we're going to look up here. We have 2 here, so I want 2. So this 9 ends up rounding, this number rounds up to 1 million. So I'll go ahead and write 1 million down. Nope, sorry, 1,000,000, so that's 1 million. Sorry for the confusion. Centimeters. Problem is, with 1 million centimeters, I only have 1 significant figure and I need 2. So now we have to put it into scientific notation. So that's 1.0, there's 2 significant figures, times 10 to the 1, 2, 3, 4, 5, 6 centimeters. Okay. I know that's squeezed in there, but I was running out of space. So we had 997,580 centimeters. I need 2 significant figures, so we round this. It rounds to 1,000,100 with 6 zeros. Sorry about the mistake there. And then, but 1 million written like this is only 1 significant figure because there's no decimal over here to tell us where that those are significant. So I have to write a scientific notation with 1.0. That means 2 sig figs times 10 to the 6 centimeters. Okay, so let's do another problem. Now here we've just been taking units that are straightforward. In other words, I'm going from a distance unit to a distance unit. Here I have a distance unit to a distance unit. But what if we have two different units, like miles per hour? That's a distance unit on top of a time unit. So let's look at this. Let's do a problem here. We'll have, let's say, a cheetah can run at a top speed that's run at a top speed of 72 miles per hour. What is this speed in meters per second? Now, I actually did this on purpose because this is miles per hour. The way we write miles per hour and meters per second, we need to write it correctly in numerical form. But so the per means divide by. So the first thing I'm going to do is write what I'm looking for. So I'm looking for meters per second. And I want you to write it that way. Please do not write it as meters per second. This will cause confusion, and I'll show you why in just a minute. So I don't want you to write it like that. And then I'm going to go ahead and start my line. We know that we have 72 miles per hour, so I'm going to write miles per hour. And now remember, we have a distance unit on top and a time unit on bottom. Do not do this. A lot of students make this mistake where they'll do 72 miles per hour and then they'll have this. So they don't have their units correctly written, and we also have a division sign on top of division sign. So please do not do that. Make sure that you have distance on top and time on bottom, or your units match. Now we're going to convert. We know that 1 mile is 1,609 meters from the last problem. So I'm going to do distance first. We can do either one. It doesn't matter as long as you're doing just one of the measurements at a time. So distance first, so we're going to go from miles to meters. We know that 1 mile is 1,609 meters. Miles cancel. Now, you notice that I already have my distance at the correct unit, so I don't need to do distance anymore. We need to take care of the time. So time is on bottom. So let's look at the hour. If it's on bottom here, I'm going to put it up top here so that it can cancel. So I'm going to go hours on top. Now the first conversion that I can think of is going from hours to minutes. And we know that 1 hour is 60 minutes. So cancel the hours. Now I'm not done because I got to go from minutes to seconds. That time unit has to be the same. So if I have minutes on bottom, I'm going to put minutes on top. And I can go from minutes to seconds, and we know that 1 minute is 60 seconds. Now the minutes cancel. So when I look at this, I can tell right away that I have meters per second, which is what I'm looking for. So I don't need to do any more conversions. I just have to do the math on the calculator. Now I want to show you how to do this on the calculator, because a lot of students tend to make mistakes. So again, here's the appropriate calculator, non-graphing calculator. And what you do is we multiply across the top and then divide by the bottom. Now I'm not going to worry about 1, because if you multiply by anything by 1, it's that number. And if you divide by 1, so anything with 1 we're not going to worry about. So it's going to be 72 times 1,609. Now at this point, don't hit equal sign or enter yet. You're going to hit divide by 60, don't hit multiply, you hit divide by 60. So I divided by 60 twice. So I went 72 times 1609 divided by 60 divided by 60. Then I hit enter. And that's the answer, 32.18. Meters per second. Now, the thing is, we need to do our significant figures, and for significant figures, we need 2 sig figs. So the answer should just be those 2 sig figs. So the correct answer would be 32 meters per second. Okay. Now, the reason I wanted to show you this is that if you do not do it the way I do it on the calculator, what you would have to do is this. You'd have to do everything in parentheses. So I would have to do parentheses 72 times 1609 close parentheses divided by parentheses 60 times 60 close parentheses enter. Okay, so you get the same answer, but you have to use your parentheses. And I guarantee you, if you're on a test, you want to do things the fastest way possible. And I have trouble on tests or when I'm trying to do things fast of making sure I use all my parentheses. So remember, it's always easier to just go 72 times 1609 divided by 60 divided by 60, enter. And that is that for this video on dimensional analysis. Our next video is going to be more practice problems on dimensional analysis. And I'll see you next time. Have a good day.